Group K, and for our senior design project, we decided to create a light automated blind system that could be attached to a current existing pair of rolling blinds. My name is Maddie Stadler.
I'm Griffin Barrier.
And I'm Keyshawn Arthur.
For our project statement, the goal of this project was to produce a device that could be easily attached to an existing pair of rolling blinds. The device will be able to roll up and unroll without any human operation throughout the entire process. It will also be able to detect light and use this detection as an indication of when to roll and unroll. The device will also promote energy efficiency during warmer and cooler months and be a commodity for those who often forget to open or close their blinds.
So our initial design, we had a 3D printed casing that housed a DC motor to rotate the blinds up and down. We also 3D printed an extra attachment that clips onto the chains well. We had to go through a couple printing processes to get it perfectly fitting for the chain. We also had a small rectangular opening at the top of the device for a photodiode to stick out and be exposed to the ambient light. And we made a few adjustments throughout the process, including changing the motor out and just changing the dimensions of our 3D printed thing to fit all of the parts that we need inside. And we used pure circuitry, so we had a circuit board opening, we had an opening throughout the casing for the motor to fit, as well as the tunnels that you can see in the SolidWorks sketch that we have.
Some of our performance goals included that lab, which is what we refer to as the light automated blind system, was able to move the blinds from fully closed to fully open in less than 10 seconds of start. The lab must complete more than 30 open-close cycles without replacing the battery, as we did rely on a battery as our main power source. The entire device must weigh less than 3 pounds, and it must be able to complete one open-close-open cycle with unmodified test blinds and also with 50% torque added to the strings. So basically the strings won't break in the process of opening and closing. And the lab must not fail accessible surface temperatures test as defined in the CPSC child safety standard after 2 minutes of on-off cycles. So basically our device won't overheat and become dangerous to the user.
So a little bit of our design rationale, we decided to use battery power instead of an external power source. The reason for this is, one, a little bit more aesthetically pleasing. There wouldn't be a cord coming from our product, and most people also would not like to see cords straight across the room. The second would just be for the actual design process. Instead of having, no one really has outlets near their windows, so a cord would be really would not work well for what we were trying to do, and the battery would just fit perfectly onto our device. Our second design rationale was pure circuitry versus a software program. This main reason was we wanted to challenge ourselves, and Arduino is just a really easy process to try to get this done. Circuitry would just be really more of a challenge to be able to do the logic and to the counter. The third reason was the rotary motor instead of linear motor. This just worked perfect with the chain because most of the rolling blinds have a chain that run down, and our rotary motor would fit perfectly onto the bottom of that and allow the torque to pull it through. Price and weight were a big constraint in ours. We decided to 3D print the entire casing solely based off the fact that it would be cheaper instead of doing a whole steel or aluminum casing around it. It would also weigh a lot less. Plastic obviously is a lot less dense than metal. And the third design rationale was trying to get all this done in one semester's time. A little bit of our engineering analysis plan. We decided to first do the stress on the pole chain to make sure that we wouldn't break the pole chain. First, obviously, the easy equation was just stress as the force over the area. So we knew the area of the little balls that connect to the chain, and then we figured out the force required to pull those down. And from that, we decided that the stress needed to be about 215 pounds, which wouldn't break the chain. The next process was the shear stress on the motor and the pulley. This was done easily just using a SolidWorks process or an Inspire process to add loads onto the motor shaft and to analyze what the stress concentration would be across that. We determined the max stress would be 62 KSI and the tensile stress would be 89 PSI. According to the material properties of this motor, it wouldn't fail, so that was one of the big things that we solved. Second would be the torque required to actually pull the chains on the motor, and that was just an easy process of the radius of the pulley times the force that we were using on the chain. And last was to determine how long we would need to, or how fast we need to run the motor in order for the blinds to open and close in 10 seconds. And this was just an easy process of figuring out the length of the pull chain, multiplying that by the time that it takes to open.
So as you can see, picture, that was our initial build for the prototype. We had our old motor still, and we used tape to hold it together just so when we were demonstrating, if we had to make any minor adjustments, we could easily open it up and fix things in our circuit. And then you can see on the bottom view just the circuit board as it's housed inside of the casing. And we now have an updated prototype right here. So we still use tape to hold the motor down because it's not the same size as the old one, so the only way we can mount it without 3D printing an entire different casing was to use a little bit of tape. As you can see, the photodiode sticking out through this area right here used to detect light, and there's a sensor on the tip of it, so it is directional. So if we moved it this way or that way according to where the window was, we can change how much intensity of light it picks up. And at the back of our device, we have a small hook area if we wanted to be mounted on the wall for convenience. And one of the main adjustments that we made was switching out the DC motor that we initially had to a servo motor, and we had to use tape to hold it together so we didn't have to 3D print a completely different casing since the hole is fitted to the old motor that we had. But the reason for the switch was just because we didn't have enough torque with our old motor. We just had a lot of speed, but it wasn't giving us what we needed to rotate the chains. So this one is a lot slower process when it rotates, but it has enough torque to rotate a heavier chain or heavier pair of blinds. And then this is our power source, our battery that we plug in to get it going. So you can demonstrate how it works now. So you can plug it up and it begins to rotate and stops rotating once the light's gone and starts back again. Do that one more time. There we go.
So all in all, not all of our performance goals were able to be met. And thinking of how we would change our project for the future, we would probably consider creating a different type of programming software and compare it to our circuit board. Griffin will talk more about this. Also, we would, when looking back at the entire semester, we had to make some adjustments. The biggest one being, as mentioned, changing from a rotary motor to a servo motor within the time span of only 2 weeks. We had to exchange out, as Keyshawn mentioned, speed for torque. So that was our biggest adjustment over the entire semester. As mentioned, not all of our performance goals were met because we were not able to get the blinds to actually close. So I'm going to have Griffin talk a little bit more about how our gates were unable to work and how, if we had more time, we would have utilized our circuit board to do this.
So for our circuit board, we wanted to add logic gates, 2 of them actually, to make the blinds close. The first one would allow the power to run the motor in the direction of opening. The second logic gate would have run the power in the direction for it to closing. However, with our logic, we weren't 100% perfect with that. We did get the opening, but the closing seemed to fail. The second part of it was adding the counter to our system. So if we did have a perfect torque motor that would allow our blinds to open in 10 seconds, our counter would shut off the power at 10 seconds, not allowing the motor to run anymore. So that would have been a much better process if we had enough time to finish that. And if we were ever to had the opportunity to run this again and get it, that would probably be our finished product and work perfectly.
In conclusion, I'd say that this project was successful, helping us be exposed to the design process for the first time. Since this is really our first time going through the whole thing, we were forced to meet deadlines and stay on top of things, follow a Gantt chart, really learn about what goes into designing a new product and see it from different perspectives, different people who came to speak to us throughout the course. So it was enjoyable, it was a learning experience, and it better prepared us for the real world and whatever we may pursue as engineers. Thanks for watching.
Thank you.